Hi, I'd like to dive straight into this discussion on privacy-first machine learning for web applications by outlining why I feel machine learning for the web is an essential feature. Slide 2. Accessibility is part of a wider effort to make applications more inclusive. By inclusive, we mean taking into account the various diverse individuals using our software and hardware and making sure they have equal and fair access without barriers. This inclusivity takes in both short-term and long-term accessibility concerns, but when we look into these aspects, we're often looking at physical considerations only, such as visual, oral, or limb impairments. Other considerations outside the physical are often ignored when we examine inclusivity, and this can sometimes mean individuals with diverse backgrounds are left behind when we build software. Slide 3. Take an application that is large and slow to load. When we build it, we can consider the market demographics, which devices, operating systems, and browsers to support. But this is, at its most fundamental, financially driven. Of course, there's always a cost and a return attributed to most development efforts, even if the cost is measured in time rather than money. With the web, we have a partial solution to this issue with progressive enhancement. We can deliver content easily, and we have been for decades, enabling delivery of most web applications without it being necessary to bundle heavy assets. Those assets are often enhancements to a product, but not essential. Slide 4. We can mitigate issues with underpowered hardware and under-delivered infrastructure by focusing on content delivery first and content enhancement second. Although we can look at simple metrics like bandwidth, latency, and feature availability, which typically is indicative of a browser version, we should be understanding the human side of this. Typically, smaller bandwidth, larger latency, and older browser support is indicative of less wealth. So by excluding those demographics to reduce development costs, no matter how small the market, you're excluding poor individuals from your content. Slide 5. This is directly against Web Accessibility Initiative's goals on accessibility, usability, and inclusion. The web is designed with accessibility in mind, with varying degrees of success. Slide 6. So this is where mobile applications differ. Consumer electronics have a premium and an inherent exclusivity. Sure, they have great support for accessibility features, but they lack some of the core benefits of the web. They're typically not great at backwards compatibility, whereas web development is considerate of not breaking experiences as standards evolve. If we want to deliver on a lot of older or less expensive handsets with native code, we have to support older APIs, and in some cases diverge code bases, which becomes incredibly costly. Weighing up the cost benefits of developing to a particular handset is entirely justifiable to most projects, and mobile prices reflect this discrepancy in quality of content. The solution to this legacy support issue for developers can often be to go web first. Deliver the content, enhance the content, and then deliver a native app if it makes sense for specific features or markets. Of course, I am simplifying a complex discussion here, and some apps don't fit into that categorization, and native apps sometimes come first. This is often the case with games, for example. Slide 7. Privacy is often a marketable feature of a product. Companies sell privacy as a value-added feature all the time. There's pro versions of apps that are definitively apps that don't have advertisements built in, and we know advertisements often come with tracking codes, so for the sake of simplicity we can assume ads and trackers are one and the same. Slide 8. This isn't a criticism of advertisements as advertisements though. If ads were delivered in an absolutely privacy-friendly way, and the user experience wasn't reduced due to increased latency or broken accessibility features, then there'd be little to complain about. When you position privacy as a luxury, then you're valuing it as a convenience. This is a naive and privileged view of privacy and exclusionary at best. Without going into real cases where weakened privacy has had a literal and material impact on lives, let's realize that this view of privacy is often taken from people in the tech industry who are privileged enough to earn a decent salary and can afford to make a decision on if and when to give up their data. By defaulting to the stance that privacy is a commodity and data is tradable, like oil, we're defaulting our products to be exclusive and framing privacy as a convenience, which costs extra. This is exploitative in most markets, as in many cases individuals will opt for a free service and give up their privacy if given the choice, and many don't have a choice in the first place. Slide 9. Let's take a look at how privacy has negatively affected the user experience on the web for a moment. Slide 10. With EU increasingly adding privacy protections into legislation, web developers have devised annoying modal dialogues which request numerous opt-ins to enable trackers in a legally friendly way. Many developers have taken issue with EU law and have aggressively argued that it's the only way to deliver web apps to the European market. Many of the apps featuring these modal dialogues have nothing to do with advertisements or e-commerce. Developers are simply defaulting to tracking users on a first load and are reducing the quality of the user experience of their apps along the way due to laziness, not legislation. Slide 10. You can deliver advertisements without tracking. So if you're monetized by ads, you don't need to destroy your user experience along the way. If you're monetized by data and tracking, then it's time to rethink your business model. How would a web app look with ad-based monetization but no tracking or data gathering, for example? Essentially, it would look the same, but without the annoying and needless modal dialogues. As developers, we're to blame, not the EU, California, or the end users. We as developers need to do better. Slide 11. So how does this affect machine learning? This is where mobile apps can already be much better. We have the capability due to hardware access to deliver personalization on mobile apps using machine learning. Slide 12. We can currently build offline-enabled models with rich tooling and bundle them with our apps, enabling personalized experiences by learning about the end user without sending data anywhere. We can even add differential privacy and federation to our models, features also available on edge devices and Internet of Things. This means we can do clever personalized analytics without looking at data. And the worst we would need to do is to send the model weights to our services for federation before updating the models again. We're not transferring data here, we're transferring anonymous weights only. This means mobile apps can create much better experiences than web apps when privacy is valued. In this way, the web is far behind in terms of privacy features. It doesn't matter what cookie protections, tracking blockers, or anonymization features you attempt to build in, if you're lazily transferring data to a central resource, you're probably not privacy enabled. Take, for example, those privacy-aware solutions that hash an individual's email address rather than storing it in plain text. When the information leaks, there's no personal identifiable information, right? Well, as most developers use the same hashing algorithms, there's a good chance you can connect disparate sources of data together to form a rather solid picture of someone. Hashes are not the finishing line for privacy, they're hardly the starting line. Slide 13. Let's segue into looking at most machine learning infrastructure currently powering moderately successful web apps for a moment. Slide 14. Typically these days we're building data warehouses, data lakes to support data aggregation, analysis, model building and deployment. At various scales this architecture is essentially ubiquitous and has been for some time, whether you were building one model or 1,000 models. This architecture is lazy. Most developers who take this blueprint and continue to re-implement it are lazy. It's commercially focused, it's driven by an excitement over the data that can be collected, and the models that can be built or the analytics dashboards that can be provided. But it's not driven by the end user, it's not driven by individuals, and it's not driven by humans. It's also expensive in the long term, but that's another discussion. Slide 15. So what does good data science architecture look like for the web? Firstly, like apps, it should be privacy first. We shouldn't be vacuuming data and then attempting to apply anonymization techniques to that data. That's like committing a crime and then bleaching the hotel room. I swear if you go in with a UV light, you'll still find evidence, no matter how hard you worked. So let's stop trying to fix the data and fix the architecture instead. Slide 16. Differential privacy is a great tool if applied correctly, but it's still not the first feature we should be looking at. Decentralization, distribution, and federation are modern approaches to data science architecture. They provide the best features for the end user, including protection by default, and they give us a little more work. Now, this may be hard for a lot of developers and data scientists to hear, but we're meant to be doing that hard work. That's what programming is, reducing the complexity of a set of tasks for the end user. So what does this approach give us? It enables us to run the inference on edge devices, and in some cases it allows us to run some of the training, whilst our infrastructure is there to do the heavy lifting only. If we distributed the training workload, we can even reduce data I/O by mitigating the need to centrally store it in some gigantic data lake. And data lakes have their uses, but they're often overused when all we really need to know is about events and weights. Slide 17. When ML operations are first-class features of the modern web browser, we can add progressive enhancement to our apps by allowing models to be executed within the browser using the best available hardware. Architecturally, our browser becomes our edge device in this ideal, and we can offload some of the inference from the legacy central platform to the end user, providing them with added privacy, more responsive results, and more personalized experiences. We can also reuse the same models that we've been building in mobile apps. Slide 18. By bringing browsers in line with native apps in terms of model inference capabilities, by optimizing usage of hardware like central graphics and neural processing units to process models, allows us to build more inclusive solutions. without which we can't build truly privacy-friendly and machine learning-powered apps. It lowers the cost of entry from a latest luxury electronic device to a favourite free browser download, and this is key to ensuring the web is a free and safe ecosystem for everyone. Thank you for listening.